Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, well, welcome everyone. Today we have with us Alex Ioffe, who, did I say that right?
Yep.
All right. Who we actually have in person in Crested Butte because the Zyverge folks are doing an offsite in Crested Butte by chance. So our friend Bill, our co-author, is meeting with his coworkers in his hometown. That's exciting. And then we get to have Alex with us. So Super fun to have you here.
Oh, yeah.
Thanks for joining us.
Yes.
Oh, yeah. It's awesome.
So my first time coming across Alex and his work was he took over maintenance for a project called Quill. And I'll have you give some background on Quill and what it is and all that. But I will just say out of the gate, it is by far the best database access technology I've ever used. I love Quill. It's fantastic. I've used it on a number of production projects and I love it. It's amazing. So thank you, Alex, for taking over the maintenance of that and taking it further too.
And I know nothing about it, so I'm going to ask really basic questions like, what is Quill?
That's a good place to
Awesome.
start.
Let's start there. So Quill allows you to interact with databases, but it's called a language integrated querying system, which is different from an ORM system.
Okay.
An ORM system is this funny idea where you can just take an object, you could put a bunch of annotations on it. So, ID column, have your one-to-many mappings with your at thing. And, you put some arrays inside, and then essentially you treat your database as a fancy hash table.
Mm-hmm.
Right? So it's like get, set. Which is a wonderful paradigm until you start dealing with these many-to-many mappings, and you loop over a many-to-many mapping, and suddenly, voila, N+1. Right? Because you suddenly, something that's connected to a list of some things, if you don't want to join everything, and then have it all in one go, but you actually want to be lazy about it, right? What do? Well, you need to start fetching every single row of the thing inside of the thing that you're querying for. So if you got, let's say, people and addresses, and a person can have multiple addresses, you get people, and then you start going through the list of addresses because you want to load it like lazily. You don't want to load everything. So then as you start looping over the addresses array inside of a given person, it needs to round trip the database for every address fetch. Hence the N+1. To get that person, you need to get that person record and N different address records. So this is like the fun thing about ORM. They've never solved this issue. So then
what's funny is that in SQL, which I hate SQL, but SQL has a very efficient way to do this. It's just that the where we lose the efficiency is in the mapping model.
Yeah.
Well, and when you look at what was the goal of ORMs? It's like, well, we know what objects are. Wouldn't it be cool if databases and the transactions with them look like objects? But so this was done in Python. There's a library in Python.
Very popular ORM.
Very popular. Yeah. No, it's not an ORM. It is.
You're right.
It is.
It's been a while since I worked with it.
Yeah, I know, and I've forgotten the name of it. I don't know if you're familiar with this.
Not in the Python.
Yeah, and it's because of the problem with efficiency with ORMs, and this is like very efficient, and it's a level of abstraction, but it doesn't try and force the object model into that abstraction just because it would be cool.
Yeah. They separated out the mapping from the queries, whereas ORMs, I think, typically combine those two things together. And it is nice because you're like, oh, I just access an object and magically it's there, and I create an object and magically it's stored in the database. Yeah. It feels magical, but it doesn't scale, and
it's just the wrong model.
It's very popular. Hibernate. I used Hibernate for many years, and it's very popular because it's simple.
What did they do in Hibernate in order to be able to get around this problem?
Second level cache.
Query, okay, fine. You have EH cache. Wonderful. So then also you have query hints. So you can query hint your way through sometimes. And you have JPQL, which is wonderful. So you go back to query strings.
Oh man, it's been so long since I dealt with all this. I'm feeling this recoiling in my body, like
Mhm.
thinking about all
Makes
this.
you anxious.
Yeah.
I've had the wonderful experience of having to work with ORM systems as well as Quill on multiple products in all of this time. So the scars are like fresh.
Mine are just what do you call it when your scab goes away and you've got the like memory of
Yes.
your skin remembers that. What's that? My brain is very fuzzy from this booster
Oh,
shot.
right. Yeah. No, that happens. So what would you say the
Scars.
mental
You said
model
scars.
might be for Quill?
So in Quill, what we do is we say no. It is a query.
Mm-hmm.
It just happens to not be a string.
Mm-hmm.
It is a query. It is defined in objects.
Mm.
You have a model for how to build queries,
Hmm.
but you're still joining stuff, and you tell it what you want to join. It does the to-object mapping part of it. That part of it is taken care of. You don't need to like deal with a result set object. It maps it to physical objects, but you do queries.
So like the Python one, it separates out the query side from the mapping side, but it handles both.
Yeah.
And we should say it's a Scala library.
Yeah.
I hate SQL. Did I say that already?
Yes, you do.
Okay, I should
On
say it
numerous
again
occasions.
because I really hate SQL. Some of the things I hate about SQL, one, there's no type system. Your type system is your database that you're talking to, which is not really a type system.
Well, it has strings, right? String is a type. Come on, give a little here.
So one of the biggest things I hate about SQL is that the type system thing, I can't actually validate that something is valid until you run it. But the other big one is that there's no like reusability model in SQL. You can't like share a part of a query with somebody. So one of the reasons why I love Quill is that I'm writing Scala code. I am doing flat maps on things to create the query. So it's actually creating the SQL query for me, but I'm writing things in typical, the way that my brain thinks about transforming a data set to form a query. So I do a flat map, I do a filter, I do, all those typical collection like operations.
Mm-hmm.
But what Quill is doing is creating that SQL query underneath the covers.
And it's smarter than you are, so it can create a much more efficient query.
Absolutely.
And that's the way the Python one works.
Yeah.
Okay.
But the other thing is that you get shareability because these are just functions that can compose. And so that's another thing that I love about Quill is I can share parts of my queries across different parts of my application.
So in a sense, you're not shifting mental. You're not having to go, oh, now I'm working with a database. Now I have to think in this different world. You're still able to work in the Scala world.
Yeah.
Okay. That's very appealing.
The other important thing to mention is that Quill gives you the query in most cases during compile time. One of the things is that if you're dealing with, let's say, a DBA team that is very, very picky about what they let you run on their database. The idea is, no, before you ship production code, they want to know what the heck you're going to run on it because they need to create the indexes that they need. And they want to guarantee that this thing will actually have performance.
So this builds the SQL query at compile time.
Yep.
So it's statically tested or statically compiled.
Yeah.
So as a developer, you're writing Scala, which you're getting validation from the type system that you're not like referencing a property that doesn't exist or a column that doesn't exist or something.
So
assuming
it's
your data
piggybacking
model
on the Scala type system.
is matching your database. But so you get that compile time validation, but then Quill creates the actual SQL query, which you see, and you can then double check and be like, thank God I didn't have to write that SQL query. I got to write Scala instead, but you can at least see and have some like validation and possibly pass it off to a DBA team so that they can.
And you're not relying on somebody's SQL quality, like my SQL is so basic that I wouldn't be able to write a sophisticated SQL query.
Yeah, that's one of the things that is hard for me with SQL is that you can really become a SQL developer and specialize in how you do efficient joins and all that kind of stuff. Whereas I'm like, let's outsource that to Alex, and I'm just going to write Scala.
Right. Sure.
In fact, in some cases, we can go one step further and we can actually execute the query, not really execute, we can execute a prepared statement for the query inside of the compiler. So if you're actually using some column or doing something wrong in the SQL, we can actually check it for you directly in the compiler. It's called query probing.
So you've written the prepared statement yourself, or is this generating?
No, it generates the prepared statement.
It generates the prepared statement. Okay.
So I've been obviously very enamored by Quill, and it works with all sorts of different databases. I've primarily used it against Postgres, but there's a Cassandra driver, and then
we support all the major database vendors: H2, Oracle, SQL Server, SQLite, Cassandra, which is the big data stuff. We also have a Spark module. We could do some really fun things with Spark that are otherwise considered to be impossible.
I haven't tried that because I hate the Spark DSL. Even though it's Scala, it's a horrible DSL.
Yes.
So I next time I have to do Spark,
that's the one that most people use the Python wrapper for.
Yes.
Let's see.
So lots of different databases. Also reactive that's what I've used in my production systems. And one of the reasons why I've used Quill over some of the other options is because it can also support the reactive drivers, the reactive database drivers.
Yeah, we get a streaming result set cursor right out of the database.
So cool.
Wow.
Maybe give us a little history on Quill. So I was getting it right that you took over maintenance of it at some point. Is that right?
Yeah.
But someone else initially created it.
Flavio Brazil, my predecessor. Hopefully we'll hear from him.
Yeah.
He
also created some of the first reactive database drivers, right?
Yeah. So he's an amazingly smart person. An amazingly smart person. Works at Twitter. So his idea, actually, Quill, sort of in his mind, was supposed to be a predecessor for something greater, but his idea was, originally it was based on work that Philip Wadler did, his practical theory of language integrated query, and Flavio implemented this paper.
Wow.
That's what he does. He finds interesting papers and he implements it. He's on that level. So the idea behind this was, when you think about systems that query databases, and you're trying to translate some logic from, say, high-level language like Scala or Java or whatever it is, you're trying to translate that into SQL. You could run into one of two problems. The first problem is, well, you just can't generate a query, right? Just, do not pass go, do not collect 400.
You mean because you don't know how, or?
Yeah, exactly. Or it's impossible. Okay. So, for example, queries can't have loops.
Mm-hmm.
Right? So if you want to be able to write a query that has a for loop inside, you can't translate that into SQL.
Mm-hmm.
So stuff like that. The other problem that you could run into is that you say, oh, that's a loop. Then what I could just do is I could take that thing, I can invert it, bubble it all the way to the top, and I can make every single iteration of the loop another SQL query, hence N+1, which is the other category of problems. So in his paper, Philip Wadler calls it the Scylla Charybdis sort of thing, where, you've got a cliff on one side, and on the other side, you go into this sort of maelstrom of N+1, where you go round and round and round and round and round and round and round. And so his idea was, if we can create a series of transformations that you can do from your Scala code or your high-level language code, and then if you follow this series of transformations, you will always be able to generate a SQL query, and that SQL query will always work, and he proves it with lambda calculus, and that's what Quill is based on. Now, I will be fair, his paper does not cover the full amount of things that you can do in SQL, like he doesn't cover distinct. So we have to improvise in certain cases. And then hence, sort of the second you want to improvise, you could do weird things. So it's nice to be able to see the query come out of the compiler So as soon as it comes out, oh, okay, this is fine.
Yeah.
So that's the idea behind it, is that go into a system where you are basically almost always guaranteed to generate something valid and something that works, which in practice holds up most of the time. There are always cases where we mess up and we make dumb mistakes and all of that, but sort of that's the premise.
Huh. So this loop problem I'm stuck in a loop on. So like you've got a loop and somehow you translate that into SQL queries?
Well, we don't have loop.
You don't have loop. Okay. So you just don't allow that. Okay.
Yeah.
All right.
Well, how do you get away with not having loops? You get away with not having loops by doing flat maps. So
some sort of recursive.
Yeah. So the idea is that the same way that you would deal with a collection, right? You can either loop over the collection, or you can say collection.flatmap. Let's say you've got a list of people and a list of addresses. You want to get all the addresses inside all of the people. So you say, okay, people.flatmap, lambda p2p.address.
Mm-hmm.
So that's the paradigm. And here's the thing. A database has exactly the same paradigm. What all you have to do is you have to sort of pretend that list of people is not a list of people, let's say, that's specific to something you're doing, but the entire table. And that list of addresses is not the addresses in every person, but the entire table. So then you're just flat mapping on two global collections of all the data. And then your join is just a filter. So we just happen to be filtering a collection of all the people in the world, and we just want to get the Joes. And then for each Joe, we just happen to want to get not all the addresses, but the specific address that has an ID which is the same one that Joe has.
I'd never really thought about how FlatMap maps so well to creating SQL queries, and that's kind of magical that there's a correlation there. And I guess that's what Wadler discovered. That through monads or flat map you can create an efficient query.
Yeah. I mean, you think about it, a flat map with one filter is an inner join.
Yeah.
That's basically what it is.
Yeah.
The question then is, how do you do outer joins? And so you need to be a little bit more clever for that.
Yeah. So Quill, what it's doing is you're writing Scala code, and then it is through some magic that I'd love to hear about. It is then creating this query based on the operations that you're performing, the flat maps and the filters and all that. How does that actually happen?
Okay. Well,
and I want to hear about new Quill, Proto Quill, and the traditional Quill.
Well, if you want to be able to generate a query during compile time, you essentially have to program the compiler. Well, how do you program a compiler?
Macros.
Okay. Or a compiler plugin, but macros is I think the simpler way to do it.
Okay.
So the idea is that instead of executing, right, you have in DSLs that execute, right, and then the execution of that at runtime is going to be your query, versus if you do it in macros, you have a DSL, but you don't execute it. You interpret the DSL. So you actually have a parser that takes your DSL, parses your DSL, and then uses the output of that in order to generate the query.
So and the output is an AST, or
it's an AST.
Okay.
Yeah. So we're working with a language. It's you take that AST and you have to take that syntax tree and you have to run it through multiple phases of transformation before you can sort of tokenize it into a SQL query. There are a bunch of transformations that you need to do to it. And some of those transformations there are intrinsic, like you have to do them or else the SQL query won't happen. Some of those transformations are there for performance reasons. For example, what we try to do is we try to flatten out the SQL query.
Instead of having nested queries. Yeah.
So you can think of any map or any flat map is kind of like a nested query. So, right, if you're saying, let's say, people.map p2p.name, comma, p.age, right? That's a subquery. Select p.name, p.age from person, and then maybe a subselect from that.
Yeah.
So,
but subqueries are expensive.
yes. The second that, database optimizers have to go through all the possible paths, and especially when they start looking into, we could technically do a merge join instead of a hash join on this particular thing, and we could merge. But no, we actually can't do that because we first need to query everything out of here, and then we have a transformation from here to here, so we can't actually do that. And we think that database optimizers are super smart, but the second you're not querying tables, the second you're, let's say, querying views that are going to themselves have a bunch of joins inside, the process rapidly degrades.
Yeah.
So the idea is that we try and flatten things out as much as we can. We try and certain kinds of things that you could say sort of duplicate or sort of copy in a query, right? This is sort of, you do it once, but we know inside of the query we can copy this logic twice. Like if you're, let's say, doing a union of some tables, right? If you're doing the union inside of an inner join, unions and inner joins are particularly very, very bad, because sort of the amount of different possibilities that your database optimizer has to explore just Cartesian
The
explosion there.
combinatorial complexity
Yes,
thing. Yeah.
yes. So what we try to do is we try to take all of those inner joins. We try all of those unions inside of the inner joins, and we try to bubble them up to the top. Well, what happens when you need to bubble up a union in a database query, bubble it up to the top? Well, inevitably, the part that selects from that union has to be duplicated. So we have certain logic that knows, we can actually duplicate this thing. So that is actually possible.
Yeah.
Versus, no, we can't do that. We have to leave it as an inner join. So in the transformations, we try and be sort of as reasonably intelligent as we can to try and make your query better.
Yeah. So when you're talking about, we've got all this stuff that at compile time creates the SQL, which is then interpreted at runtime. That's reminding me of when we talk about effects, we're doing sort of the same thing. We're creating some representation at compile time, and then we're handing it to some other interpreter at runtime. Is that?
Yes.
Okay.
Yeah, I think similar models for sure.
Mm-hmm.
Yeah.
The thing that we try to do with effects is we try and reason about them as much as we can. The problem with effects in particular is that flat map is extremely powerful. The second that you start flat mapping effects, it's extremely difficult to reason about what's going to happen from there. Mm-hmm. Unless, of course, you have a macro that can peek inside of that flat map, which lets you cheat. Mm. But unless you do that, if you're doing everything at runtime, sort of flat map is the place where it becomes tricky. But if you could reason about an effect, then you could do things like optimize things very, very nicely. Sort of, it is possible that they'll take that approach with Zio at some point in the future, where they'll actually try and use some macro-powered flat maps to actually look inside and say, oh no, this actually does not need to be a flat map. We can collapse this thing down into a map, which means that we can do all sorts of fancy optimizations on it that we otherwise wouldn't have been able to do.
So you have this system in Quill that takes the Scala code that I write, the Scala compiler creates the AST of that, and then you take the AST and run it through a series of transformations to get to the actual SQL query that's going to be run on the database.
And the SQL, when you generate the SQL query, different database systems have different optimization tweaks, right? So do you generate for like Oracle versus...
Oh, it's a whole domain of fun stuff.
I can only imagine the tedium, but...
So, for example, most databases don't have a notion of a Boolean. So what happens if in your Scala code you say, let's say, if X then true else false equals to true?
Mm-hmm.
How do you translate that into a SQL query?
So there's some fun rules that are mathematically correct that you can do with that. So essentially, we had to deal with this issue. We had to deal with the fact that, you have to have a representation of Booleans, and you can't just replace true with 1 and false with 0, because you can't do if 1, right? That doesn't really work. So we have a series of transformations that takes care of that. There are a couple of different rules that you can use that actually translate that correctly. And we have to do that for most databases, except for, of course, Postgres, and Postgres actually has Booleans sort of properly. So we have...
So you're in your transformations. So when you're using Quill, you tell it what database you're using. And so that it can then follow the path of optimizations for that particular database.
Presumably that's an easy change. In other words, if I want to switch from one database to another, it's just a configuration. Okay.
In fact, one of the patterns, it's not so popular because people don't sort of typically use multiple databases at the same time for the same data. But one of the things that you can do is write a database agnostic query. And so if you write it in that sort of database agnostic way, then at least in theory, switching databases is, a simple kind of, one-line change. Sort of it's more difficult in practice because a lot of people like to use database-specific UDFs and some other stuff. But if you do take care of that, then all you have to do is switch one thing if you're using this multi-database pattern.
Right.
Sort of instead of, spending a migration cost of 6 months and however many millions.
I have to say, because I've never really wanted to know that much about SQL, and you have reinforced with your hatred of it. I have to say, this sounds very appealing.
SQL Alchemy.
SQL Alchemy. Boing.
Got it.
Yeah, that was it.
Oh,
that's the Python one.
Okay.
SQL
I've heard
Alchemy,
of
which
it.
is quite brilliant.
Yeah.
But I think it really is along the same lines as what you're doing.
Yeah. So one of the things that I really liked about Quill was just the basic usage is obviously wonderful, but then I wanted to use JSON data types in Postgres. And I don't remember if I first had done this before somebody had written a little library for it, but it was so easy to just plug in something into this, the model of Quill, to then be able to do the JSON stuff that I was doing. And this was years ago, so I don't totally remember it, but I was like, oh my gosh, I can add in my own database logic into Quill in a way that was actually really straightforward and easy to do.
Yeah, that's awesome. I get a lot of questions actually of people trying to integrate JSON in Postgres specifically. There are a couple of different options that you have now. One of our maintainers, Matthew Dietrich, is writing a library for that. There are some other options. He's got a great library. He's supporting all the major Scala JSON libraries. And so in Quill we have a system of encoders and decoders, and because of that system of encoders and decoders, what we can do is that we can sort of say, okay, this is a piece of data that we're just going to hold on to, and throughout all of our syntax tree transformations, we kind of say, okay, this is a pointer to some other data that's going to come in at some point, sort of in the future, but for now, sort of hold on to this thing here. And so at some point in the future, or, sort of are from the level of the database, the end of the world, kind of, where you actually do execute your JDBC stuff, and you start needing to use that prepared statement and, do the setters of the prepared statement. That's when we take the sort of little pointer that we have there and we say, oh, okay, we have a pointer to some data. Oh, and we also know how to encode that data into JDBC. And then sort of at the last moment, we put it in, execute your query.
Yeah, that's cool. I think I also used it for the Postgres has a really great library for geo stuff, like being able to calculate distances between points, and I forget the name of that Postgres library, but anyways, I was able to in Quill easily like take advantage of that geo library.
Awesome.
I find it. We were talking about this a little earlier when we were out at coffee. Just when you have a mismatch between a model, often the one that you aspire to, like, because we were talking about, UML to code translators, and it often starts, and I would say economics started this way. It's like, oh, wow, physicists can predict the future. What if we assumed we could have equations for sociology? Wouldn't that be cool? We could predict the future. Let's pretend that's possible.
Macroeconomics, y equals to AKL, y equals to AKL, bow in the direction of y equals to AKL.
Right. And it's like you're going, oh, but you didn't really, and the same with ORMs. I think it was like, oh, objects are everything. Let's pretend. Wouldn't it be cool? Let's pretend if that's possible. And I don't know. It's just kind of fascinating to see when that takes us down this wrong path, and then we finally have to step back and look at it and go, oh yeah, that was a bad abstraction. It removed important information.
Yeah.
That made it a mess.
Yeah.
And it's worse when it sort of works.
What's amazing is how
or exceptions. There's another one.
Yeah, so many examples.
But they sort of work. In the small, it seems okay.
Yeah.
But then, as you get bigger, then it's like, oh, this isn't working so well. Or threads and locks. Fine in the small. As long as you can have the code on one piece of paper and you can stare at it and go, all right, I think I got all the hiccups out, but it doesn't scale.
Part of the story of technology is there are the people that have that, oh, wouldn't it be cool if
aspiration,
and then they like run into some wall, and then instead of like going back to the beginning where they started and being like, maybe that wasn't a good assumption, instead they're like, okay, I guess we need to like build a structure so that we can like get over this wall. Like they just keep on like doing hacking workarounds and workarounds on top of this, instead of going back to the beginning. It's like, let's reevaluate the foundational model.
We have an experiment that didn't work out, but I think the problem is when it works out in the small, you go, all right, let's keep going.
This is good. We've got it.
This is
just over this little thing. Over this little thing.
It's always It's like, well, here's you've got this application. Can't you add one more feature to it?
Yeah.
I mean, how you've added one more feature before? Can't you just? Yeah. And how do you explain that? No. We're one feature too far.
We just need to do a little bit of curve fitting and a little bit more curve fitting, more curve fitting.
Right.
Our quant algorithm exploded by the 2 standard deviation move. Okay, we can just factor that into the next quant algorithm.
We should explain to the listeners that you worked in fintech for 8 years.
Yes.
On Wall Street.
Yes.
So that's where some of your. So I think. I'd like to talk about Scala 3 because you've been using Scala 3, and we have been. I mean, like our book is Scala 3 based and ZO2 based, but we haven't like delved into all the nooks and crannies of Scala 3 like maybe you have.
Yeah, maybe tell us what ProtoQuill is, what you're doing there.
Oh, that too.
Right. So the idea with Scala 3 is let's rewrite Scala based on the dot calculus and have it be sort of foundationally correct. And then there was the issue of what about the macro system? The macro system is a giant hack. So we need a new macro system. We need to completely rewrite it from scratch that also has some kind of theoretical foundation.
So the Lambda macros completely blew up the idea of Lambda calculus being the foundation of a language. Right?
Yeah, essentially. But sort of there is a theoretical, there are sort of strongly theoretical macro systems, and that's what Martin Adersky wanted to do. I think based on MetaML, I think that was it's a sort of simple idea there, where kind of if you're doing a macro, you're inside of a macro and you're writing some code inside of a macro, right? And you're just saying in the macro, okay, here's the code that this macro is going to spit out, and put into the compiler, right? So I can make this variable x. Where does the variable x come from? How do we know that it exists? Whatever. I'll declare it somewhere else, and this thing will be spliced into that thing, and the whole thing will work in the end. Well, yeah, that's a giant hack. So
I like the word splicing is because that's really what you're doing.
Yeah.
Like it was quasi quotes was like the primary way that we did. Is that how Quill's macros are written? Is it with quasi quotes?
Yep.
And it was really just
what are quasi quotes?
That's a question for Alex.
So okay, well, so all languages are based on the syntax tree that they create.
Mm-hmm.
And so when they started doing Scala 2 macros, they said, wait a minute, these syntax trees are great for writing the inner workings of a compiler, but the second that we want to write functionality on top of this stuff...
You mean to manipulate the AST?
Yeah.
Right.
And we need to start manipulating ASTs in... or sort of long ASTs, not just, sort of little AST blocks, but long ASTs, because these are application level ASTs.
Sure.
So we need a system that kind of makes that more doable.
So as the developer that's using macros, you don't really want to be mucking directly with the ASTs.
Or at least
that is a
I thought that was the point of macros.
You don't so let's say that there is an AST, and you can correct me on all this, but say that there's an AST that represents an if statement or something,
Mm-hmm.
right? You don't want to have to, as you write a macro, be like, okay, I've encountered an if. Now what do I do? What does my macro do in response to that? Like, you don't want to be dealing with the actual syntax tree. You want to write your logic for your macro in something higher level that then is modifying the AST. Is that
so let's say you want to write something like if person.name equals to Joe, then A else B. What does that look like in AST land? Well, that looks like the following. It looks like condition open parenthesis select of identifier of P name close parenthesis, and then you have to, sorry, I missed a close parenthesis, and then binary operator, sorry, no, we don't have, we then do another select of equal from that and apply that select of equal, and then on the other side of the apply on the list of arguments, that'll be a literal constant of Joe, and then that's the conditional block, and then inside you have, let's say, if A else B, let's say A and B in our identifiers, so identifier A, identifier B. Right?
So that's the actual syntax tree that Scala has generated.
Yes.
Okay.
And so you, as a macro
I don't want to
author, you don't want to have to.
That's overwhelming. Yeah.
I mean, that's what the compiler is doing.
Yeah.
And that's your interface to tweak the AST.
So I want to manipulate some form of the abstract syntax tree, but I don't want to manipulate it at that level.
Yeah.
Okay.
Yeah.
So quasi-quotes.
So that was the idea. Quasi-quotes was, well, what if we could just pretend that this thing is a string that kind of looks like code? And we can interpret that string into the syntax tree if we're smart enough.
So kind of like regular expressions.
Yes.
Okay.
And it sort of worked.
Mm-hmm.
It sort of worked, and this is what the original Quill is based on. And it does work. You can do it. It's just very, very gritty, because you can just make some variable x inside of that string, just like you declare an identifier x in the AST. You just pretend that thing exists. So it's a very low level.
No type checking.
No type checking, and no checking that thing is even declared.
Mm-hmm.
So, sort of, the idea was, whoa, this is a giant hack. We need something better than this sort of low-level mechanism. So what, for Scala 3, they said was, no. First of all, we're not going to be doing like our quoted stuff in strings. Our quoted stuff will be actual Scala code. We'll just put this little quote identifier in these brackets that indicates that this is actually sort of code that we're quoting.
Okay.
So then we take that and we say, okay, now, any kind of thing that you want to do inside of that quote has to be working code. So if you have a variable in there, that variable has to come from somewhere, which means you have to declare it in there.
And the Scala compiler is checking all of this.
Yep.
Okay.
Yep. And a lot of the time, you can splice a quote inside of a quote, and a quote inside of a quote inside of a quote, and a quote inside of a quote inside of a quote. And if in that quote, you refer to variable x, that variable x somewhere down there in the parent of the parent of the parent actually has to be freaking declared somewhere, right? You can't just use things that aren't declared somewhere. Variables that you're using have to come from somewhere. And this sort of very simple idea, I think, has this really fancy name. It's called phase consistency, because every single splice is another phase of compilation. Therefore, sort of the phases have to be consistent. Okay.
It makes sense to somebody who was writing a compiler, but not necessarily the best term to use for people who are consuming it.
Yes.
So there was tons of research that was done at primarily EPFL around how to come up with this metaprogramming system for Scala 3. Is that?
Yeah.
And lots of like trial and error. And
Yeah.
I remember this is one of the big things that made Scala 3 take so long, was that they really wanted to figure out how to allow metaprogramming in a lambda calculus friendly way or something, right?
But the metaprogramming language still looks a lot like Scala, right?
Yes.
Okay.
Yes.
So it's not like you're just going through a complete, we're in some other world now, and so I have to learn a whole new language.
So there are two representations. There's the high-level representation, which is basically Scala code. You happen to be writing it inside of these two brackets with a little quote in front of it, but it is basically Scala code. That's the high-level API. The low-level API is directly on the syntax tree.
Okay.
And so you have that dichotomy that gives you sort of the high level and low level power when you need those things.
Could I write would it be possible to write my macro just in the high level syntax?
Hopefully. There are some things where you really need the power.
Right.
Like you really, really need the power if you want to be able to do something like use a variable before it exists. Okay. And there are cases for that. Like there are actual legitimate cases. Sometimes you have to go to that more low-level representation.
It's like an escape hatch from that. Okay.
Yes.
And then there's even higher level abstractions as well, like match types and some other constructs for doing macro metaprogramming stuff, but without even having to write the Scala code.
Yeah.
And I haven't explored those much, but so match types, and then is there
you could just do inlines without doing macros. So you could just have, code that, an inline of an inline, which is going to splice the inline into the inline. It's kind of like a system where you say, okay, this function, right? You think of sort of typical compiler inlining, it's sort of an optimization, but in this case, you can actually say, okay, this piece of code, we declare it as inline, which means that this thing here has to be spliceable into other pieces of code. Now, there are certain kinds of restrictions that come with that, like you can't have dynamic dispatch happening for that. Like you can't have that be a virtual pointer, right? So it's inherently going to be a static final, or not necessarily a static final, but a final. So whenever you refer to that inline piece of code, that means that you can take that and then directly splice it into something else. And the entire macro system is essentially built on that, where this is something that we declare as a piece of code that is safe to be spliced
so it's
into...
mathematically equivalent.
Yes. Yes.
So is this your favorite feature in Scala 3, or do you have others?
It is... As far as Quill is concerned, it is certainly the most useful. So Quill in Scala 3 is based on inline.
Okay.
All of the sort of new powers that it can have are all based on inline. Because we used sort of a different mechanism than inline in order to be able to get the compile time query, because you need to, like during compile time, you need to preserve all of that information coming out of the macro, especially if you're using you're transforming this query multiple times, you kind of need that. So the way we did that was with some complexities of refined types. We don't need that anymore in Scala 3
Oh.
because of this inline thing where we could take the tree and we just say that thing will exist there because it's an inline, and we can actually go into it and see what it is.
So the code's a lot easier to understand, I assume?
Yes.
Okay.
Yes.
And thus reason about.
Yes.
And this is under a project called Quill.
Yes.
Is that right?
Yes.
Okay. Well, so when this is done, will it be usable from Scala 2, or is it just only Scala 3?
So fortunately, what you can do is you can take some types of Scala 3 code and you can import it into Scala 2. If what you've done with Quill is if you've actually evaluated all of your Quill expressions, if you've actually executed those macros in Scala 3, you've compiled that code has been spliced, it is done, right? That you should be able to import back into Scala 2.13. And because of this stuff they do with some fancy transformations of the Scala syntax tree, where they can sort of take that syntax tree, modify it, and make it backward compatible with 2.13. So I think it's called Tasty Inspector,
Right.
or something like that.
But it's amazing that you could do that with macros.
Yes. The fun part is that with macros, when the macro is executed, there's no more macro. It's done. You know,
Right.
all of
files
the
are modified.
Yeah.
Okay. Oh.
So in Quill, you're using the new inlines, and then are you doing any type class derivation? I feel like I saw tweets from you about type class derivation.
So yes, the encoders are powered by a system of type class derivation. Typically that's not a user-facing thing. I try and not make those things be user-facing. So you sort of declare your encoders and decoders, and it does the type class derivation for you. It uses the Scala 3 mechanisms of type class derivation, powered by inlines. And there are a couple of different ways to do that. There's like a high-level way to do it. There's a more low-level way to do it. Sort of, I've realized that for some performance reasons, I need to do the latter, not the former, but basically it's built on that.
So you I think are pushing the usage of the metaprogramming in Scala 3 more than anybody else I've seen. Like you're using it in more complex scenarios than most other people I've seen using the metaprogramming.
Definitely a lot of rubber hits the road kind of miner's canary scenarios.
Yeah.
And fortunately, the EPFL folks, Agalos, Feng and Lee, Nicola, they've been super, super helpful. Like if they hadn't helped me throughout this process, I don't think I would have been where I am. And especially as they iterated internally, sort of many, many times, Nicola Stuckey helped me so much. I will forever be sort of in gratitude to him.
But you're kind of helping them too by creating all of these corner
yes,
pushing
yes.
the boundaries.
Yeah, exactly.
Yes. So they certainly they know a bunch of situations that they kind of need to do that they haven't done yet. A large swath of Quill is because of certain limitations that the Scala 3 macro system has, and those corner cases are driving some of the ways that I've had to do things. But it's reasonable. It's reasonable. I wouldn't say there's anything in there that's like sort of a dark and mystical thing. If anything, I think that Scala 3 metaprogramming is much more science and much less witchcraft, which was Scala 2 metaprogramming. It's the set of simplifications that they've done, I think, is reasonable.
Yeah. So how much time do you spend on Quill and ProtoQuill, and who do you have helping you?
There are a couple of maintainers on the Quill team, and they help me out with features here and there.
Mm-hmm.
I've been doing ProtoQuill mostly myself up to now.
Sure.
Hopefully I can get some more people involved. The issue is one of those things that, I love to teach this stuff, but it's hard to teach something that you don't really know yet. So
You're in a lot of exploration mode.
yes,
It's hard to involve team members in that exploration mode. Yeah. And ProtoQuill hasn't had a release yet. Is that correct?
So we're on the 6th beta. So we're on Maven Central and all that.
Okay. I really got to give it a try.
We're in Scala 3.2.
Okay.
Cool. If you just want to see some of the capabilities, I did a talk at Functional Scala 2020 called Quill and the Awesome Power of Inline.
Nice.
I've got some stuff there, and that sort of showcases a lot of these new features.
And that's on YouTube or something?
Yeah.
Okay.
Yeah, it's a Zyverge event.
Oh, okay.
So if I've used Quill on Scala 2, what as a user of Quill would be better for me using ProtoQuill? Like the internals of ProtoQuill are a lot better with inline, but is there any like end user advantage to ProtoQuill?
So there are a bunch of fun things that you can do. Fun and extremely useful. So the first thing, actually, and this is not even released yet, but I'm working with direct integrations into a very fun GraphQL system called Caliban.
Uh-huh.
And what you are able to do is that, GraphQL systems, what they do is that you can say, I want these columns or I don't want these columns. I want these filters and I don't want these filters. And what we can actually do with Quill and Caliban is that we can essentially push down, not fetching those columns, all the way down to the SQL query level. How you do that with one static query, that's another conversation.
That's exactly what I was wondering was, how in the world do you do dynamic queries, but not dynamically?
It requires some SQL trickery, let's just say. Different. I can go into that,
but we
for
don't
a long
have to
time,
look
but
at that.
Yes.
Okay.
Wow. So a query coming into GraphQL through Caliban gets translated through with ProtoQuill into an efficient matching query, SQL query.
Yeah, and so
That's
sort of
mind blowing.
Yeah, sort of as Pierre put it, or the writer of Caliban, sort of from the front end all the way to the database, you pay only for what you ask for. And
that's just the way it should be. It just turns out it's like really hard to do that.
Yes. So we can do that dynamically with columns. We can also do dynamic filters that way. And dynamic columns and dynamic filters, while still being able to do one static query, that's one of the very fun and useful features in ProtoQuill that Quill doesn't have.
That's cool.
There are a couple of other things that we can do. We can, and this is particularly for more difficult use cases where you want to have sort of complex queries particularly for use cases where, let's say you have 3 tables and many-to-many mappings in between each one. So for example, you can think of every single security database in the world, right? It has users, permissions, roles. Users, roles, permissions, right? User has roles, role comes with permissions, and you have a many-to-many-to-many. Right, so you need essentially 2 many-to-many mapping tables in between. When you're writing your query, you typically don't want to care about those in-between tables. Sometimes they have some information there that will filter or limit things or some other metadata, but most of the time you don't want to care about that stuff. And then especially as you want to go many-to-many-to-many-to-many-to-many-to-many multiple times. So certain capabilities of ProtoQuill, like the ability to use type classes in certain situations, make those things way, way easier to use. And again, this is not sort of stuff for the average user. This is sort of for super sophisticated users. This is not something that you necessarily need to do all the time. But when you're in those sort of use cases and you're like, oh my gosh, I have like 8 joins just to be able to get from one table to another table that I need, then suddenly the value proposition of some type classes actually becomes a thing.
Yeah.
So it's sort of when the alternative is pure madness.
Yeah.
So it seems like, I mean, I stay out of the database world, but I've heard that they spend a lot of time optimizing their queries and stuff. Is that right?
There's a lot of work spent around query optimization,
Okay.
and there's a lot of tools that will give you a report on your slow queries, and
All right.
then
So they do.
Yeah.
So it seems like something like this, where it's doing the work for you, would make it a pretty compelling case of saying, well, rather than doing all that by hand all the time, again and again, maybe we should switch to a system that does it for us.
Yeah. Well, and the likelihood that a normal SQL developer is going to write the right SQL, is so unlikely. Right. It's just,
I mean,
there's very few people, I'm sure, in the world that can write generally well optimized SQL.
And even
the cost is huge.
Yeah, even if they can, well-optimized SQL requires you to do horrible things. Like for the issue with the unions. You have, typically if you want something that could be something or something, and that something of something could be something or something, that's a nested union with another nested union. That's extremely inefficient. What do you do with that? You sort of normalize out, bubble it out, and then you have an outer query with, let's say, 8 unions. And being able to reason about 8 different unions, that's insane. It'll drive you nuts.
Plus,
can't handle it.
What if you decide you want to change that code? You've blown your optimizations.
Yeah. So outsource your database query optimizations to a metaprogramming model that can do it through math.
Okay. So, but I mean, a lot of people aren't using Scala. Is there a way for me to? Is there a way to take Quill and somehow put a front end on it that allows people in other languages to get benefit from
So
that?
one of the things that has been on my to-do forever has, and I haven't managed to do it yet, but hopefully as soon as all this craziness with as soon as ProtoQuill is in some stable state, I'll be able to work on this, which is, well, you're limited to the Scala compiler, so you need to use Scala in some sense, but here's the thing. Let's say you've got a Spring app. So you've got a Spring app. You have your RESTful endpoints. And you're getting tired with Hibernate N+1'ing on you all the time. Right? Well, go to your Maven or your Gradle build. Put in the Scala compiler plugin, right? Because you can integrate it because it's all JVM. Right? Put in a Scala compiler target thingy in there. Right? And then what happens? Then in your Maven or Gradle project, you'll have src main Java, src main Scala. In the src main Scala, you have your one Scala file that contains your Quill queries. Write that in, make it an object, compile that, and then you can reference that from your Java code.
Yeah.
Now, this
or anything on the JVM.
Yeah.
Okay.
There are some additional steps that you need to do, like converting all the lists into Java array lists and some other stuff just to make it more ergonomic. So that's the main part. It's just the user ergonomics of being able to do that particular thing.
But Quill is definitely dependent on Scala, and so in JVM projects, I could definitely see a place where people could have a bit of Scala that's just the Quill pieces, and then access those from Java or Kotlin. I should prototype that because I'm kind of disappointed with the database options in the Kotlin world, and I don't even write Java anymore. But I would definitely be disappointed in the Java world. But yeah, for Kotlin, it'd be a nice sample like Quill for the database piece, and then Kotlin for the rest.
Yeah, fun. That's let me know if you need anything. I definitely want to have these kinds of examples working. I think it would be huge.
They could be very powerful. Very compelling.
Wow. That was amazing. Thank you, Alex. It's so fun to have you here.
It's a pleasure to be here.
Thanks to Zyverge for letting you sneak away from the get together to spend some time with us.
Yes. Yeah. To everyone, please join our hackathon if you want to work on Quill. I have a list of some curated issues. If you're interested, please join us.
Oh, cool. Awesome. How would they find that?
search
Is this the
for
Diverge hackathon?
yeah, Zio
Okay.
Hackathon
Yeah, Zio hackathon.
Zio Hackathon. Okay.
2021.
The one we're going to go to tonight, I think.
Yeah, exactly. Cool.
Awesome. Thank you.
Thank you.